Hello students, in today's class we are going to learn F block elements, the tricks for the electronic configuration of lanthanoid elements. Let's start. Okay students, in our online chemistry class today we are going to learn F block elements, and from this we are going to learn the tricks for the electronic configuration of F block elements. Okay, now the general formula, I am writing it down. General formula for F block elements is n-2 F1 to 14 and then n-1 D 0 to 1 NS2. Okay, this is the general formula for the F block elements. Now here if we put n equals to 6, then we'll get the lanthanoids, that is its formula should be, you can see 4F1 to 14, 5D 0 to 1 and 6S2. And if we put n equals to 7, then we will get the actinoids, and its general formula would be, putting 5F1 to 14, 6D 0 to 1, 7S2. Okay, now today in this video we are going to learn the electronic configuration of lanthanoids. Okay, so what about these lanthanoids? The trick, because of the lanthanoid compounds, here we'll get from starting from lanthanum to lutetium. We'll get starting from lanthanum up to lutetium. Okay, so for all these elements, there's a trick behind it to find how to write the general formula. Okay, so the trick is, you have to understand this point. In these F electrons, there shouldn't be any 2 or 8 is barred. 2 and 8 will not come. I'm writing it here for you. For lanthanoids, F electrons 2 and 8 is not going to come. Okay, and we'll mention it again. Now from here we can start. Now if we starting from here, if we write, say for example, first element lanthanum, its atomic number is 57, and then we can write xenon gives 54, and then we'll write the F electron, D electrons and S electrons like this. So what will be the S, D and F? And you can see from here it will be 4F, 5D and 6X. So how many electrons will come here in 4F, 5D and 6S? We'll calculate it later. Now from here you can see, after lanthanum it comes cerium. Cerium is 58, then xenon, next 4F, 5D and 6S. Now the system is, starting from here, we'll write it down as all these numbers. 1, 2 will not come, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Starting this one from cerium, because in lanthanium we can write that all these S electrons will be 2 for this, and here there will be no F for lanthanium, F is 0. So by calculating this, xenon is 54 and this 56, so D electrons will be 1, only 1 D electron for lanthanium. So calculation starting from here, F electrons, for F electrons, if we give 1, so now calculate. Next it should be Praseodymium, PR, it's 59, starting from xenon, 4f, 5d, and 6s. 6s should be 2, and for 4f it should be 2 is barred. 2 is barred. So here in this case it will be 3. Okay, that is the process. Okay, I am going to tell you. So I have made it for you. You can see. So 3 is the next. In place of 2 is not coming. So 3, and from here you can write. Next is 4 for neodymium, and then 5 for promethium in F, and 6 for samarium, 7 for europium, and now you can see 8 is not going to come. 8 is not going to come in F electrons. So for gadolinium it will be again 7. Okay, so this is a trick that you have to remember. And for terbium, next you can see up to this point. Okay, for terbium it is 9. For dysprosium it will be 10. Holmium it should be 11. Okay, for erbium it should be 12. For thulium it should be 13. For ytterbium it is 14, and for lutetium it is again 14. Now all the 6s2 electrons are filled up because it is all 6s2. Now what about D? Now say for example if we take say gadolinium. Okay, now for gadolinium you can see total 64 electrons are there. So 54 is for xenon, and then say for example X electrons for D, this is D electrons, and 2 electrons for already that you have measured, it is for S electrons. Now if we calculate from here, and 7 electrons for D. Now if we calculate X, it will come 64 minus, and we calculate 63, so 1. So for gadolinium D electron should be 1. Okay, now if we calculate from here in lutetium, say for example for lutetium total number of electrons is 71, 54 for xenon, 14 for 4f electrons, D we don't know, S2. So from here if we calculate electrons over here for D electrons for lutetium, so the value that comes, if we calculate it, how much we have to calculate? 16, 70, 70 minus 70, so 1. So here is also 1 electron. Okay, so this is how we can calculate. Okay, now here in this case for say for example promethium and samarium, you can see there is already filled up by the 61 electrons, so there will be no d electrons, or rather we can write in this way 5d0 or 5d0, you can also write 5d0, so there will be no electrons for this. Okay, let me fill up all the d electrons. Okay, so now you can see from here, this is the basic system of the configuration, how to write the configuration of the d electrons of lanthanide elements. Okay, now so the basic tricks I have already done to you. For the lanthanoids, 2 and 8 F electrons is not going to come, and then after fill up all the F electrons, all S electrons are 2 electrons, and then by calculating xenon 54 and f electrons and s electron, we can calculate the penultimate shells and all other things, that how much will be the d electrons. Okay students, so in the next video we will discuss about the actinoids. Okay, please subscribe my channel, and thanks for sharing and viewing it. Thank you.